So today we're going to go over the Lineweaver-Burke equation and graph. This is an equation that we're going to use to determine whether or not our inhibitor is going to be competitive or non-competitive. So first, looking at the Lineweaver-Burke equation, it's denoted as 1 over V naught equals to Km over V max times concentration of substrate plus 1 over V max. And the graph is a linear function, so we can almost think of it as y equals mx plus b. So the b, or the x-intercept, is going to equal to negative 1 over km. And y-intercept is going to be equal to 1 over v max. And then the slope, or m, is going to equal to km over v max. And this will come in handy later on, but it's good to keep in mind that when Vmax is the same, we have a competitive inhibitor, and when Km is the same, we have a non-competitive inhibitor. So looking at the problem set, we had a set of data points, and the first thing that we want to do is find the reciprocals of each. And so these are substrate concentrations, and then we found the velocity without the inhibitor and with the inhibitor. So starting off, looking at these graphs, you'll notice that the x-axis is always 1 over substrate and the y-axis is always 1 over velocity. So in these ones, these points were just plotted out, the trend line was found, and then we were able to get our linear function that we can use to calculate for Km and Vm, or Vmax, sorry. So when we put these two lines in the same graph, this is what we get. So you can see that we have an intersection at the y-intercept. So we're going to use that to calculate for Vmax. So the intercept is at 0.0222. So we just plug that in, plug and chug, and we get a Vmax of 45.045. Now, using the Vmax, we can now calculate for our Km. So we do have the same Vmax for both lines, but we will have two different Km values for each line. So for line number 1, right here, y equals 0.224x, we're just going to use that slope, so just that tiny part right there, plug it in, and using the Vmax that we just found, we get a Km of 10.09. Now for line number 2, same thing. We're just going to begin using that little slope, and then we get a Km of 29.86. So since we have the same Vmax, it's going to be competitive inhibition. Now, if we had an x-intercept over here, we would have had the same Km, and that would have been non-competitive. So what is competitive inhibition? So competitive inhibition is when your inhibitor mimics your substrate and it's able to bind at the active site. So this is a problem because enzymes will have a hard time finding the correct substrate if both of these are able to bind. The enzyme will get confused. So what is the solution? Well, the solution is to increase substrate concentration so that it can outcompete the inhibitor at the binding site. So when you're increasing substrate concentration, it increases the likelihood that it's going to bind at the active site rather than an inhibitor binding at the active site. So when you increase substrate concentration, you are also increasing Km.